everyone, I'm Samita and I'm going to be explaining the solution to sprint number 27 of release 12509. The question reads, Lulu the magical pony's favorite number is 3. She calls a positive integer magical if it's divisible by 3 and contains exactly 3 digits that are 3. Compute the number of 5-digit positive integers that Lulu calls magical. So to begin, we know that all of our 5-digit magical numbers must contain 3 threes. So we're going to split up all of our magical numbers into two cases. The first case where the first digit is 3, and the second case where the first digit is not 3. And so for our first case here, we're only going to be considering the magical numbers where 3 is in the first position. And so we still have 2 more 3s to account for, and we have a total of 4 empty spots. And so we can rearrange those last 2 3s in a total of 4 2s 2 ways, because again, we have 4 empty spots and 2 3s to arrange. So this gives us a total of 6 ways to arrange those last 2 3s. And so now we have accounted for all of our 3s, but we still have 2 more empty spots. And since they tell us that magical numbers are divisible by 3, we can use the divisibility rule for 3 to help us figure out what these last 2 numbers should be. And to recall, the divisibility rule for 3 states that for any number, if the sum of the digits adds up to a multiple of 3, then that number is a multiple of 3. And so we already have 3 3s, so that gives us a sum of 9, which is a multiple of 3. So that means the last 2 digits must also add up to a multiple of 3 to make the total digit sum divisible by 3. And there are 2 ways we can do that. So the first way is to choose 2 numbers from the set 0, 6, 9, because these are all multiples of 3. Or we can pair one number from the set 1, 4, 7 with one number from the set 2, 5, 8. And this is because for the first set, if we divide any of these numbers by 3, that gives us a remainder of 1. And if we divide any number in the second set by 3, that gives us a remainder of 2. And so when we add a number with a remainder of 1 to a number with a remainder of 2, that gives us a total remainder of 0 when dividing by 3. And so from this first set here, any of these 3 numbers can be paired with any of these 3 numbers. So that gives us a total of 3 times 3, or 9 possibilities for the last 2 numbers. And for our second case here, we can apply the same logic. We're pairing one number from a set of 3 to another number from a set of 3. That gives us a total of 3 times 3, or 9 combinations as well. However, we have to keep in mind that these 2 digits from the second case here can appear in any order. They can be flipped. So we need to multiply this 9 by 2 to account for both of those arrangements. And so we just multiply this by 2, which gives us a total of 18 combinations for the second option here. And so for case 1, where 3 is in the first position of our magical number, that gives us a total of 18 plus 9, because this is the arrangement for the last 2 spaces. We multiply this by the number of arrangements of our 3s, so we multiply this by 6, to give us a total of 162 magical numbers for this case. And also we have the second case, so we have to consider that as well. Our second case is where 3 is not in the first digit. So out of all 5 digits, the 3s can only appear in the last 4. And so we can rearrange the 3 3s in a number of 4 choose 3 ways, because this time we have 4 empty spaces, but 3 3s to account for. So that gives us a total of 4 ways to arrange the 3 3s. And again, we have 2 empty spaces to account for, and we can use the same logic as before to figure out what those last 2 numbers can be. But we have to keep in mind that because this first digit is currently empty, we cannot put 0 in that spot. So for our first option here, the first digit must be either 6 or 9. And then the second digit can be any number from the set 0, 6, 9. Because 0 can appear anywhere, just not in the first position. So because we have one number from a set of 2 paired with one number from a set of 3, that gives us a total of 2 times 3, or 6 combinations. And again, we have this other option here that we can just copy and paste from our first case, where we pair one number from the set 1, 4, 7 to one number from the set 2, 5, 8. And again, we can do the same thing we did before, because any of these numbers can appear in the first position, does not violate any math rules. This gives us a total of 18 combinations as well. And so to find the total number of magical numbers, we do the same thing as before, where we just add up the total possibilities for the last 2 digits, multiply it by arrangements for the 3 3s. This gives us a total of 96 magical digits for case 2. So to find the total number of magical digits, we just add the case 1 and case 2. So that's just 162 plus 96. which gives us 258 total magical numbers. So the answer to this question would be option A, 258.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.